The name Kuiper may be both foreign and distant to many people, but in future exploration and expansion, he is destined to become an important gateway to the stars for mankind. Imagine that. When we start with the Earth, gradually expand outward to Mars, Venus, Mercury, the Moon, and even the asteroid belt. With the development of decades, the population of Mars and the Moon will eventually reach several thousand. And the moons of those giant gas planets, such as the large moons of Jupiter and Saturn, it will also become a new world of research and settlement for brave explorers and scientists. So what will be the end of humanity? And the answer is science. This vast region at the edge of the solar system. But why do we look so far away? Kuiper, who was almost completely new to us, took the time to explore and imagine what his value was. In addition, in order to achieve this ambitious blueprint, what technologies and strategies do we need? This video content attempts to answer these questions and reveal that those middle rivers are the fundamental reason why our species spread like waves to the edge of the solar system. While we were talking about colonizing space, our thinking is often limited to the Moon. Relatively hard-working celestial bodies like Venus or Mars. At best, we have to consider the potential of celestial bodies in the asteroid belt led by the stars, but often overlook the fact, located beyond the edge of our familiar solar system, there is an area that may be more important to our species than thought. The concept of Kuiper Belt was first developed by Dutch-American astronomer Gerard Kuiper proposed in 1951, based on research conducted 10 years ago by Irish astronomer Kenneth Egipworth. And so this region was called Wasco Boa, Egypt. Maybe more accurate, this belt region extends between about 30 and 55 astronomical units. An astronomical unit is the average distance from the Earth to the Sun. About 150 million kilometers. It is estimated that the Kuiper Belt contains at least 100,000 objects over 100 kilometers in diameter. The most famous of these is Pluto. This planet was considered the 9th largest planet in the solar system until 2006. However, Pluto is not the only notable celestial object in the Kuiper Belt. In the past 20 years, thanks to advances in telescope technology, we found many objects the size of Pluto. For example, the diameter of the star is 2,226 kilometers. Makemake is 1,430 kilometers in diameter. Homier diameter 1,430 kilometers. I am 1,086 kilometers in diameter. These are over 1,000 kilometers in diameter. These ladders are collectively known as the KBO and the Combine objects. They are in shape, size, color. There is tremendous diversity in both composition and orbit. Some have round shapes. Some are slender or irregular. Some of the colors are red, gray, or white. Some are composed mainly of sailors. Some are deck soldiers. Some are nitrogen soldiers. Some of their tracks are close to the ecliptic plane. Others show a high degree of tilt or eccentricity. Some celestial bodies have their own satellites, and each is a separate world. As they tell us the history of the solar system, challenges us to explore and understand these distant celestial bodies in greater depth. Science and technology. Kuiper Belt represents a new frontier of scientific research and adventure exploration. Although this frontier is very different from the solar system we are familiar with, As the American astronomer Frederico pointed out, if we continue to understand the solar system in outdated ways. So let's take into account the chaotic and mysterious area outside Nanyi Haiwang Line. The solar system is not limited to the planets and moons we know well, and the implications are far greater than we could have imagined, reaching tens of thousands of astronomical units, filled with countless bizarre celestial bodies. Until 30 years ago, the existence of the Oort cloud, farther away from Kuiper, is still speculative. Until the beginning, we're just beginning to really explore beyond Pluto. So, why are we heading to such a seemingly desolate and challenging place? It is true that the environment in the first wave belt is extremely harsh, very far from the Earth. It takes more than 6 hours for a communication signal to reach Earth, the Moon, or Mars. This means that communication with Earth takes at least 12 hours back and forth. In addition, about 6 billion kilometers from the Sun makes even the fastest Shinseno probe to date. It also took 9 years to reach it at 58,000 kilometers per hour. Ming Wanqing's future atomic-powered spacecraft may arrive in less than 3 years. But this requires a major technological breakthrough. At such a great distance, the efficiency of solar energy is greatly reduced. Nuclear power becomes a more practical option. The currently available nuclear thermal rocket technology holds the promise of reducing travel time to just a few years. And more advanced technology, if a nuclear pulse propulsion can reach 1% of the speed of light, although this is not enough for star missions, but it's more than enough to reach a long-range target like the Kuiper Belt, sailing with a constant acceleration. It is possible to complete a journey of 40 astronomical units in 1 month and reach 1.8% of the speed of light. It greatly simplified transportation between the colonies. Shocking. The intensity of sunlight reaching the coastal belt is 2,000 times weaker than on Earth. This means that even during the day, and it's the equivalent of nighttime on Earth. Although this environment may be a paradise for some creatures, but it will be very difficult for humans to adapt to these conditions, which are equivalent to swimming liquid. One possible solution is to use the mirrors used in concentrated solar power to amplify natural light. These technologies can not only amplify the brightness of moonlight to sunlight, it can also be used to amplify the intensity of sunlight in the Kuiper Belt. It is based on the fact that sunlight on Earth is as strong. As you can imagine, this is no paradise on Earth. But why would anyone still dream of living here? Despite the challenges, however, the science and technology belt offered many colonial advantages. And here's the thing. In order to safeguard humanity against natural and cosmic disasters that could harm the Earth, future safety in the event of a threat posed by the inner solar system, the threat of the Sun's demise is the most obvious and terrifying. Well known. The Sun cannot burn forever. About 5 billion years later, the Sun will run out of relatives it needs for nuclear fusion. The core goes out. Then the Sun will start to contract and cause nuclear fusion in the sea, causing it to expand into a red giant state. Our expanding star will swallow Mercury and Venus. And it is likely to move troops from Earth to Mars. However, the devastating energy released by our dying star is not enough to affect the outer solar system. The Earth there will also have plenty of time to migrate and adapt to a warmer climate. A brighter and more livable new environment. Although these motivations are important, but they may be more about generations in the distant future, rather than our current generations. At present, the main driving force for the colonization process of the outer solar system comes from the scientific belt. Rich mineral resources contained in millions of celestial bodies. The total mass of the main small new belt is estimated. Its celestial body contains 50 times more volatile substances such as water and annuon than the average asteroid. It also contains a wealth of useful silicate minerals and metals. The porous and differentiated nature of these celestial bodies makes them ideal for mining. But actually, and where are the settlements needed for these light activities going to be built? Colonists can choose to live in bonobo shells and floors. Using nuclear fusion and geothermal energy to extract minerals from the liquid ocean inside the ice. Mention dwarf planets. The first thing that people think of is Ming Bang and Prism. However, there are many challenges on the planet Minution, mainly due to its extreme cold and remote location. Relying on the Earth to deliver supplies is extremely unreliable. All resources must be obtained locally. Only a few necessities such as plant seeds are transported here from the Earth. The gravity on Pluto is only 6.3% that of Earth. It was a huge health challenge for the settlers. It's not clear how much gravity humans need to survive and reproduce in the long term. But it is likely that this gravitational support is higher than that of Pluto or any other scientific belt object. In addition, Pluto receives only a small fraction of the sunlight that Earth receives, making reliance on solar energy a major issue. However, compared to many other rocky bodies, Pluto has its advantages. It is located in the distant outer reaches of the solar system. Therefore, it is least affected by the sun's radioactive particles. Although science fiction often ignores the dangers of radiation, but in reality, radiation poses a major threat to future settlement plans. Settlements established in areas with low radiation, and further isolated by thick materials such as fire ice. It's very attractive. As for building materials, Pluto is rich in water ice and some nitrogen gas, enough to provide human settlers and their plants with the water and air they needed. However, the almost complete lack of energy sources such as solar energy may pose an even greater challenge. But Pluto shows signs of cold volcanic activity. If you can dig deep enough, might be able to extract rare energy from inside dwarf planets. The same applies to thin stars. It's the most massive object in the cavities. Its surface gravity is only 10% that of Earth. The most striking feature of Phyllis is its highly close orbit. It is a classic that can approach the Sun to 38 astronomical units. That's actually about the average distance to Pluto. And its origin is 98 astronomical units. This ability makes Priscilla an ideal location for establishing an interstellar service station. Most soldiers contain materials that can be used to make missile fuel. There's no reason to think Eris would be any different. In the same way, Pachyon gives rise to unique positions, ideal for establishing astronomical observatories to explore the Oort cloud and more distant celestial bodies. This prospect that we've been discussing is still very far away. Only when the Earth's civilization is highly developed, capable of traveling through the solar system and mastering various forms of nuclear fusion to provide power and inorganic energy, that's going to happen. However, a growing number of space travel experts believe that these extreme places are not just destinations for human exploration. In those huge cold worlds, the most visionaries saw the use of countless more distant celestial bodies as cornerstones. Step-by-step climb. The possibility of eventually reaching stars and stars outside our solar system. The moon is an example of this. Without him as a convenient observation platform, we hardly dream of going to Mars today. You don't have a convenient foothold. We are unlikely to consider jumping directly from the Earth to the red planet. The psychological divide is too great. Something similar is happening now with the Kuiper and Oort clouds. The Oort cloud extends to the outermost reaches of the solar system. The comets on its outer monument are almost in contact with comets from other star systems. Back in the 1990s, astronomer Carl Sagan conceived of this concept. As time goes by, human settlements will appear on comets in the Kuiper and Oort clouds. Someday, you could even use these little worlds as spaceships. Finally leaving the solar system to interstellar space, British physicist Freeman Dyson also proposed. In a few centuries, human civilization will migrate to the Kuiper Belt, and then the Oort cloud. The first is the innermost comet. It's like colonizing a big island. They will jump from one comet to another, finally reaching the outer edge of the cloud. From there, the solar system and the comet swarm of Alpha Centauri coefficients nearly merged. Humanity will make the final leap. This is obviously a centuries-old project. Any fantasies we have about them will be surpassed by future realities. Many people believe that interstellar travel is impossible. Others find it extremely difficult to achieve this goal. However, it is surprising that the ratio of the distance from Earth to Mars to the distance from Spain to the Caribbean Sea, it's about the same distance as the alpha coefficient between Earth and Mars. So if it took us 500 years to develop the technology to get to Mars, why don't you think that in the next 500 years, we would have colonized the entire solar system and expand our footprint to the Kuiper Belt? It would take a generational timescale to make such a long boat trip to the Oort cloud. But eventually the colonists who left the coastal belt would expand so widely, so much so that the colonial front would be closer to another star than the sun. Start there. Perhaps many centuries from now, their descendants will gradually migrate to a new solar system. By this means, even without a dedicated manned interstellar mission, human civilization could also gradually expand to other stars. This begins the next phase of exploring the final frontier of the universe. Exploring the boundaries of solar systems beyond our own. The Oort cloud as the final frontier of the solar system. Ultimately, it will be a springboard into the possibilities of a wider universe.